Hello everyone. So we are solving the EOQ problems, the cycle inventory problems. So this is the first one, which is the simplest of the lot. So the problem here states that demand for the iPads at Imagine Store is 1,000 units per month. Imagine incurs fixed order placement, transportation and receiving cost of $4,000 each time an order is placed. Each iPad costs around $500 and the retailer has a holding cost of 20%. We have to evaluate the number of iPads that the store manager should order in each replenishment lot in a year. Then there are other follow-up questions like what is the cycle inventory? What will be the number of orders in a year? What are the annual ordering and holding costs? What is the average flow time and what does it signify? And finally, we have to assess what will be the ordering cost if the EOQ is desired to be at 200 units. Alright. So we start by first writing down whatever the information that is available with us. Now, please note that we have been asked to evaluate the number of iPads that the store manager should order in each replenishment lot in a year, right? That's why we have to consider the annual demand. So, annual demand, which is denoted by D, is given as 12 into monthly demand, that is 1,000. So, we have 12,000 units per year. Next, we have the ordering cost denoted as S is $4,000 per order. Then we know the unit cost denoted as C is $500 per unit and the holding cost, that is H, is 20% of the unit cost. Okay, right. Now we calculate EOQ denoted as Q star as under root 2 into D into S divided by H into C. Okay, so when we substitute for each variable, we get 2 into 12,000 into 4,000 divided by 0.2 or 20% of 500. So when you plug these numbers in a calculator, you will get the EOQ as 980 units per lot. Okay. Now we have found the first answer. So the store manager should order 980 units in each replenishment lot. All right. Now we'll go towards the follow-up question. First, we have to find the cycle inventory, which is given as Q star by 2 for cycle inventory, that is 980 divided by 2, that is 490 units. After that, we have to find number of orders, that will be to meet a demand of 12,000 units, how many orders will have to be placed. So it will be 12,000 divided by 980, that is 12.24 orders. What does it mean? It means that 12 orders will be placed and this 0.24 may be added to the 12th order, or it may be a slightly less inventory may be stored. Okay. Right. Now after that, The next question is about annual ordering and holding costs. That is given as D by Q star, that is the number of orders into ordering cost plus average inventory into holding cost. This we know from second part over here to be 12.24 into 4000 plus the average inventory also we know is 490 into 0.2 into 500. This will come to around $97,980. All right. Next, we are asked average flow time, which we will remember as average inventory divided by the flow rate. That is Q star by 2 to 1 by D, or Q star by 2D. When we substitute this, it will get 490 by 12,000. That is 0.041 year or 0.49 months, which means each iPad spends 0.49 months. This is an average figure in inventory. Okay, so we are done with all the sub questions, but there is one more scenario that we have to consider now. This is the second part. Here we are given EOQ to be 200 units. This is our Q star, right? Now to arrive at this EOQ, what should be the ordering cost, right? That is to be assessed. How much should be the ordering cost? So now let's go back. We have to find value for S. So now we know that Q star is given as under root 2 ds by H into C, right? So this implies that S will be given as H into C into Q star square divided by 2 into D. Okay? So if we substitute the values over here for the different variables, we will get 0.2 into 500 into what? This is not 980, not the value that you calculated, but this is 200. This one. Okay? Do remember that. 200 square divided by 2 into 12,000. Answer will come to around $166.7 per order. So the ordering cost will have to be $166.7 per order if the EOQ is to be 200 units. Okay, right, that is the solution for this problem, right? Thank you.